And the 2 rules you have to know. The first one we've kind of already written down. You don't have to write it down again. Think of the largest number that can go into all of your numbers. You may have 7 numbers, and you have to think of the largest one that can go into all of them. So think of the largest number that can go into all of your numbers. After you figure that out, then you've got to look at what the smallest exponent is on a letter. And put both of those on the outside of the parentheses. The leftovers stay inside the parentheses. Oh, you're doing that right.
And this is the outie any?
This is just factoring out GCF. We don't even talk about outie any for a couple days. We're just practicing. You got to be able to take a GCF out before you start any of the factoring problems. So give me a second to write that down. I'm just going to underline largest number and smallest exponent. Largest number, but you got to think of the smallest exponent. I'll show you how this works.
No, I don't think leftovers are bad.
If I had this problem, and I didn't even tell you the directions, what would you say what you have to do?
Multiply. Distribute.
Distribute.
Yeah.
I didn't even have to tell you the directions. You can just see that you've got to distribute the 3x and then the 3 and the 4. Factoring out a GCF is just going backwards. It's where you're already given something and you got to take something out of the problem. So distributing and taking out a GCF work together. It's the same process. It's just going one way and then going backwards. Let me give you an example. Just watch for a second. 4x plus 12. Let's say that's our first problem. Now when we're trying to think of our GCF, first look at your numbers. You have a 4 and a 12. What is the largest number that can go into both of them?
4.
4. So I'm going to write down a 4. Do they share a common letter? Do they both have an X with them?
No.
No. So the only thing you have in common is that 4. This is the GCF. So it goes on the outside of the parentheses. The next thing you do is write your parentheses. And we are going to figure out what is still left over in here. How many times does 4 go into 4? Once. And you can just bring your X down. You didn't do anything with that letter. Do you have to have the 1 in front?
No.
No, so you don't have to ask me that. You don't have to have it. Plus, how many times does 4 go into 12?
3.
And close your parentheses. And you've taken out a GCF. If you distribute it back, you get right back to your problem. So it's just backwards distributing. Just taking out something common. Try another one.
So would you solve for x?
Is there an equal sign? You only solve if there's an equal sign. Eventually we will get to that, but not yet. 3x plus 27y. 3x plus 27y. So let's look there. We don't have a common letter, so we don't even have to look at that. But if you look at your 3 and your 27, what is your common number in both?
3.
3. That's the largest number that can go into both of them. So 3 goes into 3 how many times?
Once.
Once. Bring down your x. You didn't do anything with it. Plus 3 goes into 27.
9y.
Bring down your y. And close it off. And to check it, you just distribute it back. Right now, we're just taking out a GCF. We haven't done any factoring. That doesn't come until after we've mastered this skill. If you want to try it, 14z plus 12x. Try that one. What would be the common number?
2.
2. Don't have a common letter yet, but it's coming. So parentheses. 2 goes into 14.
7z.
7, bring down your z. Plus 2 goes into 12.
6x.
And bring down your x.
This is just doing everything backwards.
That's what I've been saying.
Why do we have to do this?
You'll see. It's done. RM plus ZN. Oh my. RM plus ZN.
Would m be the common?
Ah, yes.
Oh my God.
M is the common letter, so you can take an M out. Because
And
it's a
then
motion.
R plus
So if
Z.
you take an M out of this first term, if you just erase that M, what letter's left?
R.
R
R plus Z.
plus Z. Because Z would be the letter left in that one.
See, when you make it simple like this, something's coming up, just don't be nasty.
No, I know.
A little bit. I'm getting there.
So,
I'm listening.
what was the process for moving that in? Were you dividing M into M?
Well, it's kind of, but they cancel each other out. So you're just left
But
with
you're
the
still
R.
left over with 1. So if
You
so
could
they're
put
not
one.
actually canceling each other out, you still have 1 left, right?
No, because if you have an M and you need an M, they match up. You don't need any more. If you put an M in there, then you're going to get M squared when you distribute it. So they match up. And you're going to see where they don't, and you have to put another letter there.
Okay.
It's coming. Let's see. Let's try. Ooh, let's put the numbers and words together. 18 XM plus 16 X cubed. 18 XM. Try this one on your own, see what you can do with it. Plus 16 X cubed. What would be your common number? 2.
And also X.
Do you have a common letter?
X squared?
I just have an X
No,
here.
2X.
Here.
Oh,
I just have a common X.
So 2X. And then parentheses.
So parentheses. How many times does 2 go into 18? 9. The X's kind of cancel each other out, they match. What's the only letter you're still missing?
M,
M.
then plus.
Plus 2 goes into 16.
8.
8. The x's match. What letter am I missing?
P.
Professor AJ, if we need to, can we kind of put the greatest common denominator? Yeah, factor like off to the side somewhere.
Yeah, but in your answer, this whole thing has to be there. If you just wrote that, it's not right. You have to have that 2x in the front.
Well, because I was thinking, go 6, 9, you know, and I think until I can,
See the numbers?
I have to, yeah, write them out.
But just make sure the 2x comes in the front.
Oh, yeah.
Well,
No, I mean-
where does the x squared come into play? Because there's 2 x's there.
Right, but if you had said x squared, that means both of these would be x squareds.
Okay.
You have to look at the x squared.
So you always pair up the variable that has a common